As it stands today, we need permission from the Chinese government to make things. That's not a Chinese official. That's not a think tank analyst warning about a hypothetical future. That's James Litinsky, the CEO of MP Materials, the company trying to rebuild America's rare earth independence, speaking about the United States of America in the spring of 2025. America needs China's permission to manufacture its own products. Here's how it got to that point. In May 2025, Ford Motor Company was forced to suspend production of its Explorer SUV for an entire week at its Chicago assembly plant. The reason wasn't a labor dispute, a software recall, or a parts shortage caused by a storm. Ford shut down one of America's most popular assembly lines because the Chinese government had decided 6 weeks earlier to restrict exports of a group of metallic elements that most Americans have never heard of. Ford wasn't the only one. Up and down the American manufacturing chain, defense contractors, electronics companies, EV manufacturers, robotics firms, the same thing was happening. Production lines slowing, stockpiles running low, engineers scrambling to find alternatives that in most cases simply don't exist. On April 4, 2025, Ministry of Commerce issued what it called Announcement 18. In retaliation for the Trump administration's sweeping tariffs on Chinese goods, Beijing imposed export restrictions on 7 rare earth elements, a group of metallic substances with names most people can't pronounce: samarium, gadolinium, terbium, dysprosium, lutetium, scandium, and yttrium. The announcement didn't ban exports outright. It created a licensing system, meaning any Chinese company wanting to ship these materials abroad now needed special government approval, case by case, shipment by shipment. Chinese authorities were given broad discretion to evaluate each request, demand detailed disclosures about how the materials would be used, and approve or deny at will. The practical effect was immediate. Exporters halted shipments overnight. License applications began requiring hundreds of pages of documentation. Processing time stretched from 45 days to several months, with a significant number being denied altogether. In this video, we're going to explain what rare earth elements actually are and why they matter more than oil ever did. We'll show you how China went from zero to monopoly in less than 30 years, and why American companies handed them that monopoly. We'll walk through what the April 2025 export restrictions actually hint, what it means for the F-35, the Tomahawk missile, and the Predator drone. And we'll show you what America is doing to fight back, and whether it will be enough or fast enough to matter. To understand why 17 metallic elements could hold the world's most powerful military at risk, you have to understand what makes rare earths different from every other strategic resource, including oil. Oil is replaceable. In a crisis, you can turn to other producers: Saudi Arabia, the UAE, Canada, the United States itself. You can draw down strategic reserves. You can accelerate alternative fuels. Oil is a commodity traded on global markets by dozens of countries. Rare earth elements are different in a way that makes them far more dangerous as a strategic weapon. The entire global supply chain, mining, processing, refining, magnet manufacturing, every critical step in turning ore in the ground into a usable industrial component is dominated by a single country. China has controlled that chain for 30 years, and the rest of the world largely let it happen. Rare earth elements are a group of 17 chemically similar metals with names like neodymium, dysprosium, and terbium. They occur naturally in the Earth's crust and are found on every continent. The name rare is actually a misnomer. They're not particularly scarce in terms of abundance. What's rare is finding them in concentrations high enough to be worth mining, and what's even rarer is having the industrial capacity to process and refine them at scale. These elements have unique magnetic, luminescent, and electrical properties that make them essential for specific applications that nothing else can replicate. Neodymium and dysprosium combined into an alloy produce the strongest permanent magnets on Earth, the kind used in the electric motors of every EV. every wind turbine and the precision guidance systems of every advanced missile. Terbium and europium produce the specific wavelengths of light in LED displays and energy-efficient lighting. Scandium strengthens aluminum alloys used in aerospace components. Yttrium is in the thermal barrier coatings that protect jet engine turbine blades at temperatures exceeding 2,500 degrees Fahrenheit. There is no substitute for these properties. If you want the world's most powerful permanent magnet, you need neodymium and dysprosium. If you want a turbine blade coating that survives 2,500 degree exhaust, you need yttrium. The laws of physics are non-negotiable. Now here's how China got control of all of it. In 1980s, the United States was the world's leading producer of rare earth elements. Mountain Pass sits in the northeastern Mojave Desert, 56 miles southwest of Las Vegas, surrounded by nothing but Joshua trees and sand. From the air, it looks like a wound in the landscape, a massive open pit carved into a hillside that most Americans drive past on I-15 without knowing it's the most strategically important hole in the ground in the country. In the 1980s, it was the dominant source of global rare earth supply. American companies refined them. American companies used them. America had the supply chain, the technology, and the expertise. Then, China entered the picture. Deng Xiaoping, the Chinese leader who launched China's modernization in the late 1970s, is reported to have said, "The Middle East has oil, China has rare earths." Whether or not he said it in exactly those words, the strategy that followed was unmistakable. Beginning in the 1990s, China built state-supported rare earth mining operations in Inner Mongolia and Jiangxi province, where some of the world's richest deposits of heavy rare earths are located. Chinese companies priced their rare earths below the cost of production at Western mines, a practice made possible by government subsidies and the complete absence of environmental standards applied to Chinese operations. Mountain Pass couldn't compete. American rare earth companies couldn't compete. One by one, the Western producers closed their operations, went bankrupt, or were acquired. The processing facilities shut down. The workforce dispersed. The institutional knowledge, developed over decades of practical experience, walked out the door with the workers who carried it. By 2020, China produced approximately 97% of the world's rare earth elements. By 2025, it produced 60% of global supply. That number sounds like improvement until you realize that China also processes approximately 90% of all rare earths, regardless of where they're mined, because the rest of the world shut down its processing infrastructure. Until recently, China accounted for 99% of global heavy rare earth processing, the specific category where dysprosium and terbium live, the elements most critical for defense magnets. The only processing facility outside China for heavy rare earths, a single plant in Vietnam, which has been shut down for the past 2 years due to a tax dispute. China didn't achieve this monopoly through technological superiority or geographic luck. It achieved it through patient, decades-long strategic investment backed by state capital, combined with pricing strategies that made Western competition economically impossible. And for 30 years, American companies and the American government largely let it happen because the rare earths were cheap, the supply was reliable, and the strategic risk seemed theoretical. On April 4th, 2025, it became very real.
To understand why the export restrictions hit so hard, you need to understand what these 7 elements actually do, and why just finding an alternative is not an option. The most important application of rare earth elements, from both a commercial and military perspective, is the neodymium iron-boron permanent magnet, also called an NdFeB magnet. Here's the simplest way to understand why these magnets matter. Every electric motor that needs to be powerful, precise, and compact uses them. The motor in a Tesla Model 3, the motor in a Chevy Silverado EV, the motor in a wind turbine generating electricity on a farm in Iowa, the actuators in a humanoid robot's arm joints, the guidance system in a Tomahawk cruise missile, the control surfaces in an F-35 fighter jet. All of them use permanent magnets, and the best permanent magnets, the ones that are small enough, light enough, and powerful enough to do the job, require neodymium for their base structure, with dysprosium or terbium added to maintain that magnetic strength at high temperatures. This is critical. An NdFeB magnet without dysprosium or terbium loses its magnetic properties at temperatures above roughly 250 degrees Fahrenheit. Electric motors and jet engine components routinely operate at temperatures far above that threshold. Without dysprosium or terbium to stabilize the magnet's performance at high heat, the motor or guidance system fails. Dysprosium and terbium are both on China's April 2025 restricted list. And the restriction has a technical detail that almost no coverage explained. China didn't just restrict raw dysprosium and terbium. Under Announcement 18's extraterritorial provisions, any product containing these elements, even if only 0.1% of the product by weight consists of Chinese origin material, requires a Chinese export license to be shipped from any country to any other country. China's licensing system reaches into the supply chains of Japanese and European magnet manufacturers who use Chinese raw materials and asserts discretionary authority over where their products can be sold and to whom. That means China's export controls don't just hit American importers. They reach into Germany, Japan, South Korea, any country that relies on Chinese rare earth inputs in its manufacturing chain. Now think about what that means for the American defense arsenal. The Center for Strategic and International Studies published a direct answer to the question of which American weapon systems depend on the elements China just restricted. The F-35 Joint Striker Fighter contains approximately 920 pounds of rare earth materials, according to a Congressional Research Service estimate that the Pentagon has cited publicly, embedded in its flight control systems, radar, and engines. The Virginia and Columbia-class nuclear submarines carry rare earth elements in their propulsion systems and sonar equipment. Each Virginia-class submarine requires roughly 9,200 pounds of rare earth materials total. The Tomahawk cruise missile uses rare earth magnets in its guidance and propulsion systems. The Predator and Reaper drones carry them in their motors, cameras, and sensor arrays. The JDAM, the precision guidance kit that turns a conventional bomb into a smart weapon, requires them in their navigation components. Every one of these systems is affected by the 7 elements China restricted in April 2025, and the Department of Defense stockpiles, while not publicly disclosed, were assessed by CSIS as insufficient for an extended conflict scenario. In a prolonged conventional war, the rare earth supply would become a binding constraint on American weapons production. Here's the part most coverage got wrong about these restrictions. A licensing system sounds less severe than an outright ban. It isn't. An outright ban is binary. Every country sees it clearly. Every country begins planning around it the day it's announced. A licensing system is discretionary. China can approve licenses for companies in countries it wants to reward. It can deny or delay for countries it wants to pressure. It can demand detailed disclosures about end uses, essentially requiring American defense contractors and their suppliers to tell Beijing what their products are going to be used for before they can receive the materials. And when the US and China reached a 90-day tariff pause in May 2025 in a broader framework in June, the truce did not touch Announcement 18. That original April 4th framework, covering the 7 core elements, remained fully in force. In December 2025, China began issuing general licenses that ease throughput for civilian commercial customers, but defense and aerospace applications were explicitly excluded. As of mid-2026, exports of yttrium, dysprosium, and terbium were running approximately 50% below their pre-restriction baseline. China traded a partial temporary easing for real tariff concessions and kept the licensing infrastructure in place, ready to be tightened again whenever Beijing decides the conditions are right. Which brings us to the hardest part of this story: why rebuilding America's rare earth supply chain is so much harder than just reopening a mine. Mountain Pass, California, the mine that MP Materials reopened in 2017, is actually a rich deposit. It contains significant quantities of neodymium and praseodymium, the elements used in the base structure of NdFeB magnets. The problem isn't the ore.
The problem is what happens after you dig it up. Processing rare earth ore into usable rare earth compounds is an extraordinarily complex chemical operation. It involves dozens of sequential steps: crushing, grinding, flotation separation, leaching with hydrochloric acid, solvent extraction through hundreds of large vessels called mixer settlers, each producing hazardous chemical waste that must be managed. The process requires specialized chemical expertise, proprietary process knowledge, and infrastructure that takes years to build and billions of dollars to fund. For decades, Mountain Pass sent its ore to China for refining because China was the only place with the processing infrastructure at commercial scale. MP Materials, even as it rebuilt the mine, was still paying China to process its output. When China announced the April 2025 export controls, MP Materials was forced to accelerate its own on-site processing capability. The Defense Department struck a $400 million deal with MP to support the build-out. In August 2025, the Trump administration opened a $1 billion funding line for critical mineral supply chains. And in a factory called Independence on the outskirts of Fort Worth, Texas, MP Materials built something that didn't exist anywhere outside China, a facility that takes purified rare earth oxide and turns it into finished NdFeB magnets, controlling the entire supply chain, from mine to magnet. The plant is targeting approximately 1,000 metric tons of finished magnets per year in its first phase. In February 2026, MP announced a second facility named 10X that would bring total annual capacity to 10,000 metric tons when both plants are operating. GM is their first automotive customer. Apple has signed an agreement for magnet shipments beginning in 2027, after the capacity expansion is complete. That's the good news. The bad news is the timeline. China has built approximately 50 rare earth separation plants over the past decade. The rest of the world has 3 facilities capable of creating rare earth oxides at commercial scale total. Building the processing infrastructure to meaningfully reduce dependence on China takes a decade minimum, requires sustained political will, and costs tens of billions of dollars that private markets won't provide without government guarantees.
The rare earth weapon is not new. China has used it before. Understanding the history is understanding the strategy, because Beijing has been playing this game for 15 years, and every iteration has been more sophisticated than the last. In September 2010, a Chinese fishing trawler collided with Japanese Coast Guard vessels near the disputed Senkaku Islands in the East China Sea. Japan arrested the Chinese captain. China's response was swift and targeted. Within days, Chinese customs officials began holding up rare earth shipments bound for Japan, citing inspection requirements. The informal restriction lasted approximately 6 weeks. Japan is the world's largest producer of NdFeB magnets. Its entire manufacturing base for electronics, cars, and industrial equipment depends on rare earth inputs. The message from Beijing was unmistakable. The Senkaku dispute has a cost, and we can make you pay it precisely where it hurts most. Japan released the captain. The rare earth shipments resumed. 15 years later, China used the same playbook, but this time against the United States, at a scale and with a sophistication that dwarfs the 2010 episode. In October 2025, China expanded its initial April restrictions to cover 5 additional heavy rare earth elements: holmium, erbium, thulium, europium, and terbium. These elements are critical for downstream alloys, magnet materials, and certain manufacturing equipment. The expansion also extended extraterritorial jurisdiction, meaning Chinese authority now reaches any product anywhere in the world that contains as little as 0.1% Chinese origin rare earth material. A Japanese magnet manufacturer using Chinese neodymium to make a magnet that goes into a German wind turbine is now subject to Chinese licensing authority over where that product can ultimately be sold. China isn't just controlling raw material exports, it's asserting discretionary control over the global rare earth magnet market, anywhere, at any stage of the supply chain if Chinese material was ever involved. The scale of American exposure to all of this is stark. The U.S. imports approximately 80% of its rare earth elements from China. Close to 90% of rare earth compounds and nearly 90% of rare earth magnets consumed in the U.S. come directly or indirectly from Chinese supply chains. China produces about 60% of the world's raw rare earth supply and processes approximately 90% of global output, including material mined in Australia and Myanmar that gets shipped to China for refining because there's nowhere else with the capacity. The U.S. has one operating rare earth mine at commercial scale. One, Mountain Pass in California, operated by MP Materials. It employs approximately 700 people. China has built 50 separation plants over the past decade. The processing gap is not measured in years, it's measured in decades of infrastructure, expertise, and institutional knowledge that doesn't exist outside of China. In October 2025, the Trump administration struck an agreement with Australia to begin reorienting American dependence on China for critical minerals. Australia has substantial rare earth deposits. The Halleck Creek project in Wyoming, operated by Wyoming Rare Inc., is estimated at 7.5 million short tons of rare earth oxides, 5 times the estimated reserves at Mountain Pass. But Australian ore still needs to be processed, and the processing infrastructure doesn't exist in Australia or the United States at the scale required. The 2025 agreement was a start, but industry analysts note that building out the processing capacity to meaningfully substitute for Chinese supply will cost tens of billions of dollars and take a minimum of 10 years under optimistic assumptions. The paradox is brutal. To build processing facilities that reduce dependence on China, you need capital that private markets won't provide without government guarantees. You need engineering expertise that has largely migrated to China over the past 30 years. And you need time, at least a decade, during which China retains the ability to throttle supply at will. The Trump administration committed $400 million to MP Materials and $1 billion to the broader critical minerals program. For context, China has invested approximately $50 billion in its rare earth industry over the past 2 decades. The numbers don't close a 30-year gap. Here's what China's own strategists know that most American coverage ignores. This weapon has a self-destruct mechanism. China's rare earth industry employs hundreds of thousands of workers. Its magnet manufacturing sector generates significant export revenue. Every time China restricts exports, it accelerates the very diversification efforts it's trying to prevent, pushing Japan, the EU, and the US to invest in domestic supply chains with an urgency that commercial economics alone would never produce. If American and allied manufacturers genuinely achieve supply chain independence, if Mountain Pass scales to full processing capacity, if Australian and Brazilian deposits get developed, if recycling technology matures to the point where magnets can be reclaimed from end-of-life products, then China's monopoly dissolves and the weapon disappears. Beijing is aware of this. The more aggressively it wields the weapon, the faster it builds the case for the investments that will eventually make the weapon useless. That long-term dynamic is real, but the short-term asymmetry is also real. In the next 5 to 10 years, China can inflict serious economic damage on American manufacturing and defense production at essentially zero cost to itself, while the United States is still building the infrastructure that would allow it to respond in kind. Beijing understands this window. Announcement 18 was the signal that it intends to use it.
In 1980, the United States was the world's leading producer of rare earth elements. It had the mines, the processing facilities, the expertise, and the industrial base. The elements that power the F-35, the Tomahawk, and every American EV were produced domestically or sourced from allies. Over the next 30 years, American companies one by one exited the rare earth business, outcompeted by Chinese producers who priced below cost, subsidized by a government with a 40-year strategic plan, operating without the environmental constraints that made American production expensive. The United States effectively handed China a monopoly over the foundation of its own advanced manufacturing and called it free trade. On April 4, 2025, China filed the paperwork on what that monopoly was worth. Ford shut down its Explorer line,
Defense contractors started auditing their stockpiles. The CEO of America's only rare earth miner said out loud that his company needs permission from Beijing to make things. The response has begun. Mountain Pass is expanding. The Fort Worth magnet plant is producing. The Pentagon is writing checks. Australia has signed agreements. Wyoming's Halleck Creek project is moving forward. But rare earth processing infrastructure takes a decade to build. China has had 30 years. The gap between those two numbers is where American national security lives right now, in a window of vulnerability that Beijing opened deliberately, and that Washington is racing to close before the next crisis makes the cost visible in ways that can't be explained away. It hides in the periodic table, in the components of products you use every day, and in the supply chains of weapon systems that keep American military power credible. That's what makes it so effective. Subscribe to World Shift and turn on notifications. Every day we bring you the stories that live underneath the headlines, the technologies, the supply chains, and the strategic decisions that are quietly determining who holds power in the world your children will inherit. Understanding what's coming starts today. We'll see you in the next one.